In this module, we will talk about the basic part of a fermenter, actually the stirred fermenter. In our previous module, we talk about 7 different systems that should be the part of any fermenter. So, in this module, we will talk only about the basic parts in stirred fermenter. So, the first basic part is the body vessel. So, body is basically that vessel or a container in which the fermentation process has to be carried out. Basically, when we say that we have to the mass culture of the organism, and organism is the hero of the fermentation process, and the fermenter vessel or a body vessel act as the stage. So, the stage is very necessary. So, the ideal stage is very, very critical in fermentation process. So, the body vessel, all kind of the fermenters have the body vessel. Either that made up of glass, either that is made up of stainless steel, either that is made up of bricks when we talk about the biogas digesters. So, first basic part of a fermenter is a body vessel. The second, that is the agitator, agitation system. Agitator basically, you can see here, in this diagram you can see that just to clarify the agitator system, there is a separate from the main body vessel. But you can see inside that there is a agitator system. In agitator system, in a later slide, we will see that what are the part of the agitator system. So basically the impellers and motors and the shaft is included in agitator system. So that is known as agitator. And then is a sparger. As I have already told you that sparger is a device that give the uniform supply and distribution of the air into the fermentation medium, that give the proper shape to the air bubbles inside the fermenter. So these 3, body vessel, agitator and sparger, are 3 basic parts of any stirred fermenter. So you can see here that an agitator, in this diagram you can see that an agitator consists upon a drive motor and then a speed controller that control the speed, first that monitor and then control either how much RPM we have to required. So speed reducer first record and then first monitor and then control. In some fermenters there is only a monitoring system, not control system, but in a modern fermenter then monitoring, control and record system is available, and this is a mechanical seal, because when we talk about the agitator system, then that motor should be out of the body vessel, and then that has to be attached with the internal body vessel, because then the link is from the outside to the inside is through the mechanical seal, very critical in a fermenter design. So if the seal is not good, then there is no good fermentation process, because there is a golden chance of contamination. So the seal in a fermenter is very critical. Now in a laboratory scale, some fermenters are available, just their agitation system based upon some magnetic action, but there is no any link between the outside to inside. And then there is a shaft, and then these are the impellers. So the impellers have 6 blades, 4 blades and different type of the blades. But here you can see that in this, these are the baffles, and here you can see is a sparger, and there are different probes, are oxygen probe, pH probes. In some fermenters that is attached on the top plate. Sometimes if there is a larger fermenter, they are placed on the side wall of the fermenter. So in the next slide we can see easily that if we will design our fermenter, so we should know the basic that how we will assign the body vessel. So in this slide you can see that HT is the total height of the fermenter, and L is designated to the height, that is the working volume height of a fermenter. So in a fermenter, head space is very critical. So in straight fermentation, we can use the 75% of the total volume of the fermenter. The remaining 25% will be the head space. That's required for antifoam addition, that required for the gaseous exchange, etc. So the head space is very critical. So HT is the total height of the fermenter, and L is the height of the working volume inside the fermenter. So the H and L having a very critical, which we will talk in detail in the later modules.